All right, are you ready for this? Yay! It's the moment you've all been waiting for. It's U substitution. The crowd goes wild. Okay. Uh, Anyway, U substitution is awesome. And basically what you do is we're using U substitution anytime we have something a little bit more complicated. So something that we don't know how to integrate otherwise. This says it's used as a last resort because there are a lot of times that algebra would fix that you could do it with algebra. So, you know, when we saw something like y over the square root of y, the first thought would be like, oh, should we try U substitution or something? Like later you're gonna see things, you're gonna be like, oh, I think I should use U substitution. But I want you to look at it and realize that you can actually use just algebra on that one. You know, like this is y times y to the negative 1/2. And then from there, you know, you could use algebra and integrate it without ever having to do U substitution. Because U substitution, sometimes there have to be kind of some specific conditions for it that you will see. But it is so great, and it really makes really complicated integrals so much simpler. The one we're going to see a lot in this class is under the radical. So it's going to be like we want to find the integral of something like this. And we see that we don't really know how to integrate that because it's a function inside of a function. Other things that you could see are just basically any function inside of a function. And actually, if you want to see more U substitution, I have another video posted by a lady named Nancy. She's really good. She talks about a lot of calculus stuff. And it's on our calendar on the right-hand side in the green. There's another video, and she goes through lots of different U subs and talks about all the different types of functions that you might see U subs in. And so, basically, what we're doing is we're subbing in U for our inside part of our function, so we make it an easier function. So if you think about chain rule, we have like the peanut and the chocolate, right? A lot of times what it is we're taking out that peanut, replacing it with U, and then we integrate it and then put the peanut back in. So that's the long and the short of it. Okay, so there's steps there if you want to read them, but let's just get right into it and let's see how this works. So this is something we don't know how to integrate. Otherwise, we really have no idea what to do at this point because there's two things multiplied together. And so we got to figure out how we're going to substitute in. And we're going to substitute in U. I don't know why they chose U, but it's just the convention. It's always U that we sub in. And so you figure out you want to sub in U for some expression of x or some function of x. And the rule of thumb is usually to pick the more complicated one. Like if I subbed in x for x right now, that wouldn't really do anything because it's just one variable for another. But you want to figure out something complicated, maybe the peanut. Look for the peanut, the function inside of a function, because then you get rid of that second function. So basically, I would say look for the peanut. So what's our peanut in this one? Well, it's x minus 1. So U equals x minus 1. And so we can sub in U everywhere we see x minus 1. We put U there, dx. But the problem is we're not in terms of U right now. We're still in terms of x and U, which is even more complicated. So let's get rid of that other x. So if U equals x minus 1, what does x equal? If I add 1 to both sides, I get the x. U plus 1 equals x. So anywhere I have an x, I could just sub in U plus 1. U plus 1 times the square root of U dx. But here's another problem. Our differential is still dx, which means I still have to integrate this with respect to x. But I don't have any x's. And we don't do double integrals in this class, so there's nothing I can do here if I'm trying to integrate with respect to a variable that doesn't exist in my integrand anymore. So what do we need to do? Well, we need to have that be du, right? We need to find the derivative of u, and then we can plug that in. So, well, if u equals x minus 1, what does du equal? The derivative of u is just 1. So wherever there is a 1 dx, sorry, it's 1 dx, because the derivative of x is dx, and the derivative of u is du. So everywhere I see a dx, I can replace it with a du. So here's my dx. I'm going to replace that with a du. And now I can do some algebra to get this in a way that I can actually do it. So we have u times u to the 1/2 plus u to the 1/2 du. So that would be u to the 3/2 plus u to the 1/2 du. And then we're just going to go ahead and integrate that, because now this is simple. This is just two monomials added together. I guess they wouldn't be, it's not really a polynomial because they're fractional exponents, but anyway, it's two terms added together. We know how to integrate this. So it would be u 3/2 plus 1 over 3/2 plus 1 plus u to the 1/2 plus 1 over 1/2 plus 1 plus c. So that equals u to the 5/2 over 5/2 plus u to the 3/2 over 3/2 plus c. And, you know, we can rewrite this a little bit nicer and cleaner. So this is actually 2/5 u to the 5/2 plus 2/3 u to the 3/2 plus c. Okay, so this is our integral, but I never asked you to give me the integral of u. I asked you to give me the integral of x, right? I don't care about u. U isn't my variable. So what do I do now? Well, I know that u equals, way up here, x minus 1. So everywhere that I have a u, I'm just going to put in x minus 1. And that is the whole thing. This is the integral of x times the square root of x minus 1. And you see that subbing in the u, like we take out the peanut and make it a u, it's so much easier, and then we put the peanut back in. And so it's so beautiful. Like we go from something really crazy down to something really simple, and then we're able to come out with that. You know, like that's a really complicated integral right there, and it came out pretty simple because we could just change it to u. Let's take a look at another one. All right, so we're going to integrate this one. And again, we look for usually a lot of times, all the time, you will see the derivative of the peanut somewhere in there, and you'll see that here in a few examples. Hopefully there are some more that you can see. Yeah, we will do some more complicated ones. But anyway, we're looking here. This is the most, we're going to look for the most complicated thing, and we're going to sub in, right? So what's the most complicated one? What's the peanut in here? What's the function inside of a function? It looks like a 2x plus 3 is our function inside of a function. So u should equal 2x plus 3. And therefore x, we also need to get rid of x, right? Because if I did this, make that bigger. 2x minus 1. Man, I'm all over the place tonight. 2x minus 1 over, that's u. All right, I started subbing in, but now I need something else, right? I need that x to go away. So, what does x equal? We subtract 3 from both sides, and we get u minus 3 equals 2x. So x equals u minus 3 over 2. So everywhere that I have an x, I can just sub that in for u minus 3 over 2. So I have 2 times u minus 3 over 2 minus 1 over the square root of u. And I still have dx in there, right? So now I got to take care of that dx because I'm not integrating with respect to x. I'm integrating with respect to u, so I can't have dx there. I have to have du. So let's figure out what du is. Well, the derivative of u, du equals 2 dx. Right? The derivative of u equals 2 times the derivative of x because I just took the derivative of both sides. So everywhere that I have a dx, I can replace it with du. But first I'm going to get dx by itself. Sometimes you're going to get dx by itself and sometimes you're not. When I learned u sub, we always got dx by itself. Sometimes it's actually easier not to get dx by itself. So just know that. But all I have over here, right, all I've got right here is a dx. I don't have a 2dx. I can't just sub in 2dx for du. So I need to get dx by itself. So du over 2 equals dx. So I'm going to make that, just going to replace that dx with du over 2. And now I can do a little bit of algebra and we can get this integrand taken care of. So I have 2 times 2 cross each other out. I shouldn't say cross each other out. They become 1. I hate the term cancel out because so often people are like, oh, that means nothing is there. And it's like, not nothing. Usually it's a 1 or something there. So if we do that, then we just go ahead and simplify that. That's the integral of u minus let's see, I'm missing something. I think oh yeah, no, I think I'm good. Minus 4 over square root of u du over 2. And so then we're going to go ahead and simplify that. U minus 4 over 2 square root of u du. And then, hang on, let me make sure. Okay, and then we're going to go ahead and simplify this because this won't work because we still have something in the denominator. So we're going to go ahead and look at this as u over 2 root u minus 4 over 2 root u du. And then we're going to simplify that some more. That's 1/2 u times u to the 1/2 minus, we can make that du, minus 2 u to the 1/2, negative 1/2, which should both be negative 1/2 du. And then that becomes 1/2 u to the 1/2, let's add those together, yeah, du, minus 2u to the negative 1/2 du, and I have less than a minute to finish this up. So we're going to go, that's going to equal 1/2 u to the 3/2 over 3/2 plus 2 u to the 1/2 over 1/2 plus c. And in the end, that's going to be 1/3 u to the 3/2 plus 4u to the 1/2 plus c, and then we're going to sub that back in, and I'm just going to write this, and hopefully this is what we got. 2x plus 3 squared minus 4 times 2x plus